Hey class, today we're talking about absolute value functions and graphs, and this is section 2-7, part 2 of your book. Our objective is to graph absolute value functions. So in example 4, we are identifying transformations. So it says without graphing, what are the vertex and axis of symmetry of the graph y equals 3 times the absolute value of x plus 2 plus 4? How is the parent function transformed? So again, we've already talked about how to find the vertex. We can find the vertex basically from our shifts here. Okay, the plus 4, remember, is in the y-intercepts position. So in other words, it is your vertical translation. And because it's plus 4, it has moved it up 4. Then the plus 2, because it's on the inside of the parentheses, tells us our horizontal translation. And it is opposite of what we think. So because it's opposite, we want to think right, but really it's left. So this means that it's moved left 2. So if you think about it, when you move up 4 and left 2, remember left, this would actually be your x, right? And this would be your y. As an ordered pair, that vertex would actually be -2, 4, because we went left 2 on the x-axis and up 4 on the y-axis. And then our axis of symmetry technically goes through our x-coordinate, or our x coordinate. So our axis of symmetry is going to be equal to x equals -2, because it's the vertical line that's going to go through our vertex. All right, in try 4, it's asking the same thing. So again, let's be mindful of what we're writing. So even though we have this -2 in front, it's not going to change what we have going on as far as the vertex and the axis of symmetry. So minus 3 means that it's moved down 3. And the -1 is opposite of what we think. So instead of moving left, it's actually gone right 1. And remember, this is our x, this is our y. So as an ordered pair, our vertex is going to be 1, 3. Okay, and then our axis of symmetry, so I'm just going to put AOS, our axis of symmetry is going to go through our vertex, so it's going to be x equals 1. Okay, so to answer that final question, though, to ask how has it been transformed, it's been transformed by going down 3, right 1, and actually it has also been reflected. That -2 is telling us that it's been reflected and stretched. By a factor of 2. And if I forgot that on the last one, I apologize, but I did mean to write that as far as how it's transformed overall. All right, in example 5. So it says, what is the equation of the absolute value function shown in the graph? So we're given a graph this time, and now we are asked to write the equation. So it all starts with our vertex, okay? So our vertex, we have gone, our vertex is here, okay? And we have gone left 1, right? Left 1, and up 4. Okay, and remember our basic setup is y equals the absolute value of x. Okay, so what we've done so far is we've added the 4 to the end, and left 1 is opposite of what we think. So it's not negative, but it's +1. Then, if everyone can kind of see this, it's been flipped over. So it is going to be negative. So it's a reflection. So it's negative. And then remember to kind of figure out what this number that's supposed to be in front of the absolute value is we would count the slope if you want to call it slope, of the right arm. So I see a point here as my vertex, and I see that it's going to cross again definitely right about here. So if I count that slope, that's down 1 and over 1, 2, 3. So that's going to be negative 1/3. This here is our entire equation. So we should get y equals negative 1/3 in parentheses, x plus, not in parentheses, absolute value of x plus 1, and then plus 4. Let's look at our try. All right, guys, so again, we're going to start at our vertex. So here's our vertex, and we want to figure out from the origin how we got there. So we went down 1, and then we went right 2. So setting up our general format, we have y equals, we want to save some space. Okay, the down 1 is -1, and the right 2 is opposite of what we want to think. So instead of it being a positive 2, it's really -2. Okay, and then lastly, we want to count our slopes. So here's the original. Okay, here's where it's going to cross again. So we really go up 1 and over 4. So if that's rise over run, that's 1/4. And it's going to be regular 1/4 because the V is opening upwards. Okay, guys, so this is our final equation. If you have any questions, don't forget to come see me for tutoring.